Today, talk about Chapter 5, Introduction to DNS. I want to do both of the lectures today, Chapter 5 and Chapter 6, and then we'll have on Thursday a larger lab time to do those. For those of you who haven't got DHCP finished, to finish that up, and to do the DNS configuration. I said the first day, this, when you look at it, this ought to be really easy, but some of this stuff can be kind of confusing, and we go from one service to the next service to the next service, and they're really not related. The only way that we could really relate DHCP to DNS is that we give a DNS server address in our DHCP properties so that users have some place to go to look things up. DNS important? Why? Every domain. How many IP addresses do you know of the sites that you go to? How many of you know Facebook's got probably somewhere around 5,000 or 6,000 IP addresses? Anybody even know one of them?
No.
I don't either.
I don't like Facebook very much.
Doesn't matter, but what do you like?
Nothing really.
Nothing really.
No, I'm kidding.
Where do you go? On the internet. On the internet. Where do you go on the internet?
Google mainly.
Google. Do you know its IP address?
No.
No. You know how to find its IP address?
Uh-huh.
How?
I can ping www.google.com.
www.google.com. And if you do, you get the same address every time?
Probably no.
Because they have multiple. I mean, they would have a really tough time making all our connections on one IP address, don't you think? So they spread those things out. That's why Facebook has so many IP addresses. We don't remember those. That's what DNS is all about. Active Directory, and in the next chapter, Chapter 6, you'll do an Active Directory install. Active Directory absolutely depends upon DNS to find the resources. I told you the story about the guy at Blue Ridge who had all those static addresses. Why? So I know where all the machines are. Can you imagine keeping a paper database of 400 computers and trying to look up all of those IP addresses?
Big spreadsheet.
Big spreadsheet. That's what DNS is all about. That's how Active Directory finds its resources. It keeps the information in the Active Directory database and uses DNS to display it. Really is kind of sort of what happens there.
You have to have Active Directory. Do you have to have Active Directory in order for DNS to work?
Do you have to have Active Directory in order for DNS to work?
Yeah.
No. No.
No.
No. I mean, do you have Active Directory on your machines right now? I would say the answer is no. Have you gone to the internet on your machines? No, but some people probably have. How did they get to the site? DNS, and that's part of what we're going to look up. We can have, and that would be called a caching-only server. That just goes and looks up IP addresses for names that we use. And then we can have an Active Directory DNS, Active Directory Integrated. And we have primary zones and secondary zones and stub zones and all sorts of zones, and those are the things that I want to go through. And then they're going to have you configure. They'll have you do those things. I want to demonstrate it first, and then you can use. Hopefully, it'll make more sense when you do it. But the basics of the DNS, the domain name system, and its terminology. Terminology is always the key to IT, I think. There's nothing really magic about or mystical about what's done. It's knowing the language. Configure DNS clients. What do you do to configure DNS clients? Usually what we do is say just get it automatically, right? Because we've configured DHCP correctly. If we haven't, we can go in and put an address of a DNS server in there, even if you get a dynamic address and you don't get a dynamic DNS server. Those are two separate configurations now if you choose to do it that way. So we can configure those things. Typically, clients are configured to get everything automatically through DHCP. So if we configure DHCP correctly, we don't really have an issue there, do we?
Either you can configure the DHCP correctly, or you can go manually and put the DNS server on each
You can do either, yeah. Or if you even have DHCP configured correctly and then something changes and you want to, you maybe temporarily use a different DNS server, you can go in and make modifications for that. Install a standard DNS server on the Windows Server 2008, that's just adding the role. And then you're going to eventually, and I don't remember which chapter, install it on your core server with the OC setup command. And then you're going to do some zone transfers. I want to show you the zone transfer, what it does. Create standard DNS zones. A standard zone, and what I want to do is, in the demo, go through the different zone types. There are 3, actually 4, with the stub zone. What do each of them do? Why use these things? So DNS, translate, we know that human-readable names into IP addresses because computers do numbers really well. We're not necessarily real good at that. You remember a whole bunch of websites, I bet. www.somewhere.com, .u.com, you@me.com, those things like that. But how many of the IP addresses do you remember? I don't even remember the address of the virtual server. Do you guys know it? I know it's 199 something. So those things are what DNS does for us. Well, it does all these things, translate, assist in the flow of email. When you get into email, the email is a 2-record process. An MX record, mail exchanger record are the records that email servers use to exchange records. Those are basically what SMTP uses. And then we have an A record. So the MX record is the zone, and the A records represent single IP addresses, represent resources. Supported by the Internet by thousands of distributed servers on DNS servers. You've probably heard, what do you got to do to bring down the Internet? What would be the quickest way to bring down the Internet? Destroy DNS, right? The 13 DNS servers, right? You've heard that, right? The 13 DNS servers, huh? Yeah, yeah. Well, kinda. That's what I want to show you here. I hope in this. Ping them all. Well, here they are.
That's a lot more than 13.
There's 13 addresses. When you look in the root hints of DHCP, there are 13 servers. They're the same server, they're in different locations. They look up the same stuff. So you're going to bring this down? These 13 servers down?
Good grief, there's a ton in
yeah, there is. Europe's got a whole bunch, huh? Not so many in the U.S.
Not a lot in Russia either.
Not a lot in Russia, yeah, or China. So when we talk about that and when you hear people say that, all I got to do is bring those 13 servers down. There they are. And there have been attacks. I think in February of this year there was a DNS attack, which actually did slow things down. Each of these, and when you look at and please do look at the root hints, each of these represents a top-level domain, and we'll look at top-level domains and how that stuff works here in just a second. But I think that's kind of an interesting one. This is root-servers.org. Be careful the way you spell it, because if you spell it wrong, you get a porn site. That's why I got it up before we started here. I know. Certain words you put in there. But that is, I think, an interesting map. root-servers.org is the location. So DNS, really big deal. Translate, provide those things, supported by thousands of distributed servers. I want to show that because they talk about the 13 servers, and there are 13 root servers, but they're in multiple locations, as you can see by that map.
Like a short lease?
I'm sorry?
Are they working on a short lease?
They're a short lease?
Yeah.
They have static addresses.
Okay. Then how does that
DNS needs to have a static address. 13. Well, when we get to the configuration, I'll show you the addresses. How does it know where to go? That uses locational routing, so that even though you can have the same, multiple sites have the same IP address, and top-level routers route them to the closest one. It's called locational routing. So they can be configured for locational routing so that you go to the DNS server, or your DNS server goes to whichever one is the closest to you.
Someone having the same name in a different country.
Exactly, same name, a different country, yeah, something like that. Terminology, namespace, domain, and these come up. Fully qualified domain name, that's the one that you hear on and on and on and on and on. A fully qualified domain name, a www.yahoo.com. A NetBIOS name would be RKE-room111-INSTR would be a computer name. The fully qualified domain name would take the NetBIOS name and append it to the domain. The domain is registered. The domains are the yahoos.com, and we're going to look at how that looks in the lookup here in a second. Hosts are the individual machines, host names. DNS record is what we are going to have, and we'll look at the records, a number of different record types that go into DNS. The one that does the lookups for us is an A record. And I alluded to MX records. MX records are for email servers. NS records, name server records, are for DNS servers, public DNS servers. DNS servers that resolve your names to IP addresses, ecpi.edu, for instance. What are those? www.ecpi.edu. We'll look at some of those things. The DNS namespace organized in the following domains: the root domains, top level, second level, and subdomain. I got a picture here in a second, so I want to go on to it. The DNS domain is the portion of the namespace to the right of the host name. Boy, that's really helpful, isn't it? It's the stuff after the first dot. www.yahoo.com. Yahoo.com would be the namespace. The top level domain would be com. The second level domain would be Yahoo. www.ecpi.edu. ecpi.edu would be the domain name. edu would be the top level domain. ecpi would be the second level domain. And then we can have subdomains under that if we need them. Fully qualified domain names are the whole name. www.ecpi.edu is the FQDN. So these things, the top level domains, .com, .edu, .gov, .net, .mil, .net, .org, and they have added some. They've added the XXX, the biz.
Why do you have two .nets?
Because that's what they put on there. Somebody made a typing error, I'm sure. When we do a lookup, we're going to have two types of lookups. And those of you who had Linux, you probably heard this. We're going to have an iterative lookup and a recursive lookup. A recursive lookup says just tell me the final answer. That's what the computer wants. If I want to go to news.google.com, that's the IP address I want sent back so that I can get directly there. That's what computers want. DNS servers normally don't do that. DNS servers normally do what are called iterative lookups. This is the vendor technology. I want to try something over here to see if I can make this thing draw some lines. Turn the pen on. Server support, bentech.net. Let's say that I've got a machine over here, and I want to go to one of these Bentech things. The first place the computer looks is in its cache, and you can see that with ipconfig/display DNS. You can see what is cached. Any time you go to some place, it's going to go into the local machine's cache. That's obviously going to be the quickest. The hosts file, which we'll talk about in a few minutes, and they've got an activity for you to change the host file, also gets read into the cache. So the first thing we're going to look at is it in the cache of the local machine? If it's not, we're going to go to, and we'll call this one over here our DNS server. We're going to go to our DNS server, which will look in its cache to see if it has that information. Anytime a DNS server looks something up, it caches it. So it's going to look, the first thing going to look in the local machine cache. If that doesn't work, then we're going to go to our DNS server that we've configured in our IP in our NIC configurations. If it doesn't have something, it will go to the root, and the root's represented by a dot. The root will then refer us to whichever of these top-level domains works. Let's pretend that this is ECPI, edu, and we're trying to get to www.ecpi.edu. Our name server didn't have that information, so it went to the root. The root will then tell the DNS server, hey, I don't have an address for www.ecpi.edu, but I do have an address for the edu servers. So it sends that information back to my DNS server. I then go to the edu server. The edu server says, I don't know where www.ecpi.edu is, but I know where the ECPI name server is. It sends that information back to us. We then go to the ECPI name server. It says, oh yeah, I've got a listing for www. And it then sends that IP address back to our DNS server. That's the iterative lookup, iterations. It then sends the answer back to my computer, which is the IP address that I'm trying to get to. That's the recursive portion of the lookup. So DNS servers themselves normally iterative lookups. Computers simply want the answer. Top-level domains, root top-level domains, second-level domains. That's where they fit in. Now, if I can figure out how to get the pin off, this is kind of what they did. Hosts a computer on the internet that provides a specific resource. A computer. That's all that is. A host name is the name that we give that computer. Does it matter what the NetBIOS name is? Think about this one a second. What if I want to give something a NetBIOS name of one thing and then use it on the internet for a different name? Can I do that? Back to the people in different locations having the same name. Can we give it more than one name? Yeah. Because when you go using the fully qualified domain name, when you start using DNS to resolve it, it doesn't care what the NetBIOS name is. All it cares is what the IP address is. The server that we have right now, ranger.ecpi.net, is where you get to the web page. I changed the name of it to something else, interactive solutions. I don't remember what I called it. Doesn't matter. DNS. What's listed in DNS is what the systems use. What we use for looking up things. The www is the internet. Ping something. Use the DNS to do that. Fully qualified domain names. Active Directory, that's what Active Directory uses. Active Directory, when you register the machine, it actually takes the NetBIOS name and registers it, and that's another activity that you'll do. The DNS zone is a collection of common collected nodes. That's really served by an authoritative DNS name server. Introduced a couple of things here. Connected nodes. What does that mean? It means that they're all got the same ending. Authoritative server means that we can actually go in and make modifications. We're going to have authoritative and non-authoritative. authoritative is the starting point for this information. The non-authoritative means it got it from somebody else. It got the information from somebody else. When we were going to www.ecpi.edu, the ECPI name servers would be the authoritative ones. Those are the ones that the owner can make changes to. Our DNS server would have given us a non-authoritative answer. And when you use NS lookup, and that's some more activities that you'll do, they will do those. The DNS records that provide the information stored in this database, and there are a number of records. The A record is the one that you'll see and use the most. The A record represents a computer name and IP address combination. IPv6 uses 4 A's. That's the only difference. So if you see something that has A, it's an IPv6 A record or host record. The root domain, DNS zones with delegation. What delegation allows you to do, and I think that when you installed Active Directory and DNS came up and said couldn't delegate something, when you delegate a zone, you delegate it so that somebody else can manage it. And the only thing that you have in it is a name server record so that you go there to find the resource records. Iterative query, we looked at iterative and recursive queries. Iterative DNS client requests the best answer the DNS can provide. Recursive client requires an answer from its DNS server. Recursive, just give me the answer. Iterative, and I think these words are a little deceiving. Iterative goes one step at a time. And that's the ones that's a better picture of what I made up just a few minutes ago. DNS resolvers, DNS clients. DNS resolver is another vocabulary thing to tuck away. DNS client service to perform the DNS queries on behalf of the client. So it's there. We can configure it. Uses the client service to do that. There are a couple of services that really need to be running, like the spooler if you're going to do printing. The server client and the server service and the client service. If they're not running, you're going to have some issues with lots of things. First DNS server in the list is the preferred DNS server. So and in this we can have multiple servers. And when you do the core server, you're going to have an index number, index 1, index 2. Index 1 is the first one in the list. Index 2 is the second one in the list. If you have a third one, it's index 3. That's what that one is. The preferred server is the one it's going to look at first. If it doesn't get an answer, then it's going to try some other ones. In the older systems, the only time it'll go to a second server is if the first server's down. The suffix is the DNS name appended to the unqualified name. Queries are a query that contains only a host name. DNS suffix is something that we're going to append, and they're going to have you create some suffix in these things. Different machines, by the way, this address 4.2.2.1 is a legitimate DNS server. It's a Google DNS. It's a public Google DNS server. I continue to recommend, if you're going to use your own machine first, to put 127.0.0.1 so that when you change things up here, it's still looking at your machine for your DNS. If you change the IP address, if you put 192.168.100.10 and that's the address of the machine, and we change the address of the machine to 192.168.10.100 or 100.100, we also have to change the IP address of the DNS server. If you use 127.0.0.1, it's always going to look to the local host. To me, that's particularly for Active Directory, that's the safest way to go, because regardless of what the IP address is, it's always going to be looking to itself for DNS resolution. For setting the preferred DNS server, the net shell command, and they have that net shell interface, they kind of leave some things out. So be sure you check to be sure that the command isn't a misprint in the book, or use that little PDF that's in there. The PDF, I think all those commands work. I've used most of them. One of the things that they had you do to rename the server, they use the WMIC command. You can also rename it with a netdom command now that you've gone through the pain of doing the other one. And the netdom command seems to be a little bit simpler to use. Dynamic updates. What this means supports dynamic updates. Linux supports dynamic updates. When we looked at the advanced configurations of DHCP, one of the options there was to allow DHCP to update the records for the machines that couldn't do it for themselves. Windows 2000 on up can do it for themselves. What this means is if the server supports dynamic updates, that when the computer comes online in a domain, and this is typically going to be an Active Directory thing, it will register itself, put its name and IP address into DNS so that you can now find those resources. DDNS, dynamic DNS, and there are services, by the way, that will provide that for you on the internet if you want to do that, if you want to look up your home machine by name instead of by IP address. The DNS install is a role, nothing magic about that. I think one of the first labs of this chapter has you take DHCP off. Don't do that. Just leave it on. Just leave it on. A caching-only DNS server, back to the question that I think Josh asked, does it only work with Active Directory? No. Be called a caching-only server. Caching-only server just doesn't have any zones listed in it, and we'll look at zones and creating zones here in a minute when we do the looking at the configuration. It only goes to the internet and finds the IP addresses of the Googles and the Yahoos and the Microsofts and the Netwares of the world and keeps them. We'll look at the caching also, the records that it keeps in there. What that means is that we now are listing those things locally so that the lookups are quicker. They talk about it. I really hadn't found it to be all that slow to find DNS resolution. I guess that the real issue would become if somebody starts a denial of service attack against DNS, then you'll have it listed here because they're going to attack at the larger scale, at the top level. That's where an attack, that goes because there are too many of the others. The root hints, the IP addresses to the top level DNS domain names, and when we look at the demo, don't let me forget to look at those. They're really uninspiring. A, B, C, D, E, really, really clever names. A, B, C, D, E, those kinds of things. Those are the ones that provide the referral answers. When we went to the root sends you to the top level domain. The top level domain sends you to the second level domain, and hopefully the second level domain will either send you to a subdomain or it'll give you the IP address of the system that we're going to do. We also have this thing called forwarders, and what a forwarder says that servers use to resolve names. What a forwarder says that if it's not listed here, go someplace else to get it. The system that we use here, we use OpenDNS for most of our resolution. When you go to a DNS server here, it looks to see if the zone's listed. That would be all of the roanoke.ecpivab.edu stuff, which would be all of our Active Directory stuff. If it's not, there are others there, other ECPI stuff there. If it's not listed there, then it sends the request to OpenDNS, which then sends the answer back to it. So forwarders just simply forward the request instead of going through all the iterative lookup. That's the one time that a DNS server doesn't do an iterative lookup is when you set in a forwarder to send the request someplace else. Zones, building blocks of the infrastructure, we're going to look in these ways. Classified in three ways: the information they store, where they store it, their read-write status. What kind of information are we going to store? Where is it going to be stored? And this one gets in here because of Active Directory. Active Directory doesn't store its records in the DNS database. It stores its records in Active Directory. And Active Directory then provides that list to DNS when it starts up with the net logon service. If you have an issue and you don't want to reboot the machine, use a net stop net logon and a net start net logon and see if it'll load the Active Directory files into DNS. The read-write status, this is going to be primary, secondary. We'll do that in the demo when we do those things. Two categories, standard and active directory, standard zones, and active directory integrated zones. The standard zones are stored in the DNS database. The active directory records are stored in the active directory database. Zone.dns, %system root system 32 DNS folder, C:\Windows system 32 DNS folder is where that database is going to be, where the DNS records are going to be. Berkeley Internet domain name bind is industry standard, and I think that's what all, honestly, at least the major ones use. Somebody may have an odd one out there, but the Berkeley Internet name domain bind is the standard for DNS servers for the Internet. Unix uses it, Linux uses it, Windows uses it. A primary zone that's authoritative, and authoritative means that we can make changes to it. We own the right to make changes to it. It's where it starts. ECPI.edu starts at ECPI Virginia Beach. They can put other records in there. We can get the information, but we can't put records in there. The secondary zone is a read-only version, and why would we want that? Because maybe we want those records stored locally, so that if something goes down and you can't get to the other server, you still can resolve information. A stub zone is a read-only zone that only has the name server records. Why would you want to do that? Well, if you didn't want to go through all that iterations and we wanted to have maybe a zone listed, a name server listed for ecpi.edu, we could put that in there and put their name server records in there, and I want to go through that process with you. Forward lookup zones, direction of the zones, forward lookup zones, take names and resolve them to IP addresses. Reverse lookup zones, and you don't have to have reverse lookup zones. You can take IP addresses and map them to names. Those can be handy in your own system sometimes when maybe you have an IP address, you know the IP address and it's doing something really weird. Then you can use reverse lookup to find the name that IP address goes with. There have been at times in a spamming issues where some of the email providers use a reverse lookup to be sure that the emails that you're sending come from a real domain. So there are functions that these things have. The resource records information, the owner, the time to live, DNS records don't last forever. Because we wanted to change something, we would like for it to expire at some point. The class and the type, the A record, what kind of record are we going to have? The resource record data, what is actually in those records. The start of authority is a starting point for the information of a zone. That is going to be part of the zone, is be part of a stub zone. Where does this thing start? Who is the authority of it? And the name server record identifies the name servers, the DNS servers. NS records identify DNS servers. That one is in the book. A host record, an A record, provides a name to IP address resolution. The AAA records are A records for IPv6. I map host name to IPv6 addresses. MX records are mail exchanger records. Specifies a server that is responsible for handling email. And again, in the email world, you have to have two records. You have to have an MX record and an A record. If you're having mail server problems, be sure that both of the records are there. Alias record is something used to create an alias for a specified host. If we had a www something something whatever, and we wanted to also use a different name, that's what an alias record would be for. You can create an alias record to type a different name in those things. And I think that some people, large companies, large corporations, large internet presence, use this to create records for people to make kind of standard typos, so that the standard typo will resolve to that name. So an alias record just says, If I type this in, go to the other location, or it'll actually point to the other record. We can look at that also.
Like an autocorrect as well.
Autocorrect, yeah, kind of like that. Autocorrect, that's good. That's a good way. Pointer record resolves an IP address to host name. Pointer records, PTR records, are reverse lookup zone records. Service locator records, SRV records. This is when we get into the Active Directory stuff. That's able to find domain controllers so that you can authenticate. That are able to find KMS servers, the key management servers, so that when you install software, Windows in your domain, it then can find that server and automatically authenticate, put the key in for you, give you a key so that valid software. Those are the records that are absolutely critical for DNS. A zone transfer, master server, zone transfer just simply means we're going to store a copy of the records, and we're going to do that in the demo. We're just simply going to store a copy of the records from some other zone in our server. That's kind of cool, right? You can get everybody's records that way. The default configuration for zone transfers is no. You have to authorize zone transfers. Be very careful about authorizing zone transfers. I've got, so that you can do it in the labs, I've got the server, the Ranger is set up so that it allows to any server, but only internally. So, I mean, that's the only place you can get to it. You can't get to its DNS later. The master server, the slave server, gets its updates from the master zone. In this one, if we transfer the zone anytime a change or when a change is made to the master server based on the timing for the zone transfers or the zone checks, those changes get transferred to the slave or to the secondary. And this one's going to be a read-only. It's a partner specified zone transfer tab. We will look at those also. Incremental zone transfers means that it only sends the changes instead of a full zone transfer. The first time you have to have a full zone transfer, you get all the records, and somebody makes a change, you get an incremental zone transfer, which makes updating much quicker. Query, SOA, start of authority query, start of authority response. These things are serialized, so it checks to see where it is in the update process. If it's got everything, then nothing gets transferred. If changes have been made, then the response says, the SOA, notice everything in Windows, they talk about push, everything in Windows is really pull. You go over here and it says, oh yeah, I have an update. Instead of sending you the update, it says ask for the update. So then you ask for the update and then you get the update. So everything really winds up being a pull process where the destination is asking for it. Make any sense? DNS, this is a start. Take a break here, and then we'll look at some of the management. Then I want to do, like I said, I want to do some demos. DNS is a really big deal. If you have DNS not working in your Active Directory environment when you get there, Active Directory ain't going to work. You've got to point to the location where the record, where the resources are. This is another one in my little feeble-minded way. Go through the process. Be the packet. Okay, I'm going to go here to look this up. Is it there? If the answer is no, it's not going to find it. Is there a forwarder? Is there some way for that one to say, hey, I don't have this information, but go here to get it? If that's the case, follow through the train. Don't just say, hey, it don't work. If it don't work, you've got to figure out why. Then you need to make the change to DNS so that it goes to where that resource is. Standard zones classifications, and again, I want to look at those when we do a demo of those. So right now, let's take a break, and then we'll do the other one, and then do a demo. Maybe we'll do the demo and then do the other one.